We'll be going over an example on how to plot our Mohr circle for strain. We're going to be reviewing this example that we started in class, having the deformation of this figure into the deformation of this figure. Before we start this, I want to review where we're going to get our plots from. So in our Mohr stress circle, we are going to have the following equations we'll be going by. Remember from last time, our normal force, which is usually on our x-axis, is equivalent to our lambda equation, which is going to be our 1/2 lambda 1 plus lambda 3 plus 1/2 lambda 1 minus lambda 3, all times the cosine of 2 Triton. That is going to be our x, and our y, again, is going to be our gamma, which we calculated to be negative 1/2 lambda 1 minus lambda 3 cosine, sine of 2 Triton. Now this is all assuming our normal orientation, but remember when we're looking for the strain, we're looking for the inverse of everything. So when we actually calculate things out, we're going to be using our lambda prime, which is going to be 1 over lambda, and we're going to be using our gamma prime, which is gamma over lambda. So keep that in mind when we start plotting up all of our diagrams and looking at the numbers. So going back to our example here, we are going to be deforming our original sample. We're going to be shortening it by half and elongating it by 100%. So that is going to give us an elongation factor. So E1 is going to be 1, and our E3 is going to be negative 0.5. So this is based on our principal direction, maximum direction, and our minimum direction. And remember from our quadratic elongation equation, we have that our lambda is equal to our original length over our deformed length over our original length squared, or 1 plus e squared. So if we take that into account, our lambda 1 is going to be 1 plus 1 squared, which is going to be 4. And our lambda 3 is going to be 1 minus 0.5 squared, which is 0.25. We want to plot this up on our Mohr stress strain diagram, just like before. So we're going to be plotting things up. So it's going to be our gamma prime, it's going to be our lambda prime, all right, now just like we did with the previous Mohr circles, we need to find where the center of our diagram is going to be. So we need to figure out our radius, which is going to be 1/2 our lambda 1 plus lambda 3, and that's going to give us a 2.1. So we're going to plot over here our 0.25. We're going to plot over here our 4. Right, so this is our lambda 1, which we got from up here. This is lambda 1, lambda 3, plot here. And we're going to do our circle with our center at 0.21. So there now is our Mohr circle. And based off of our deformation angle, which we got from our ellipsoid, right, if we follow our material line based on our 25, we plot up our two Triton. So we go up by 50 degrees. So we go to here, go over to 50. Make sure I get this right. Right, and that is the points on our diagram, which we will label P. And if we bring our values down, that will give us our strain values, which should be 1.1 for our lambda prime, and should be about 1.4 for our gamma prime. Now remember, we want to convert back from our gamma prime to our gamma, and our lambda prime to our lambda, and our gamma prime to our gamma. So we want to do, let's equal 1 over gamma, which if we take out our calculator, if lambda prime equals 1 over lambda, then lambda equals 1 over lambda prime, which equals 1 over 1.1. Which gives us 0.9. That is our lambda value. Now to calculate our gamma prime. Gamma prime equals gamma over lambda, which should be, we're going to figure out gamma, again equals lambda prime times lambda, which is 0.9 times 1.4, and that is 1.26, which lines up with our stress circle, our strain circle, and everything comes out.